video is going to take ER diagrams to the next level. And what that means is we're just going to get a little bit more detail about the relationships between the different entities that we created in the previous exercise. So to refresh your memory, I will skip back to the outcome of our last video, which was this entity relationship diagram that basically shows you the different entities, in this case customers, orders, and items, their relationships, which are represented by a rhombus, and their attributes, which are represented by ovals. So now we're going to actually look at the more traditional view of an ER diagram as you might see it just before you put it into a database format. To do this, we're going to actually use what they call a crow's foot method. Now, there's several methods of accomplishing the same goal. I chose this one simply because it is a very popular method for depicting relationships in a database. However, the book, I believe, uses a different symbology. So here we are. The first thing we want to do is recognize that we are starting with three separate entities. We have our customers, our orders, and our items. And those entities we're going to be drawing a little differently. The attributes will actually be right inside of these boxes for each of these entities. So the attributes for customers are here, orders, and items. In green, we have what I've identified as the primary key. The primary keys for each of these are in green, and we'll go through and you'll recognize where the foreign keys are, but one of the big things to note here is that all of these have relationships, and just by drawing these lines here, you can almost see how the data is moving throughout these three particular entities. So for example, we have customers, customers place orders, and orders contain specific items. Now, we can actually say a lot more about each of these different entities, but before we do that, let's just talk about orders and items. We have lots of items, and we have lots of orders. And orders can contain many items, and there are many items that are contained within an order. There's some items that aren't contained within an order at all. However, the combinations between these two are almost limitless. So we need to find a better way of associating orders and items together. So how we do that is we actually create a couple of additional keys in our entities, or attributes in our entities, to reflect both the order ID. So now this is a foreign key, order ID, and it points back to orders. But we're also going to have an order item ID, and that is actually going to point to this intermediate table or intermediate entity that represents each item that would be in a particular order. And here it has its own primary key, which is in yellow, mainly because it's also a foreign key. And it also has the order ID and the item ID. Now, technically, you could eliminate the order item ID altogether, but in this case, I'm going to keep it here just for clarity's sake. So now we need to understand better the relationships between these four entities. So if we start at customers and we take the example of just one customer, and we look at that example of one customer and their associated orders, you can say a lot of things about it. For example, one customer would have one or many orders. A customer may not have any orders at all. So there's two cases. The customer could have a lot of orders or more than one order, but then the customer could exist with no orders at all. The way that we represent this is with this symbology here. So the crow's foot here represents the many in this relationship. So a customer can have many orders, so it fans out in a way. Now the 0 here, or the circle, represents the fact that a customer doesn't have to have any orders at all. Now, if I do the same on the order side, if I look at orders and pull one record from the orders, or one tuple, and I say I'm looking at one specific order, I know that that one order can only belong to one customer. So only one, and only one customer can be in one order. So this is represented by the two parallel bars. And if you look up in this top right corner, you'll see the key here, and this represents one and only one. Now, if I look at orders in terms of order items, an order has only one order item. That's wrong. No, I'm sorry, I said it wrong. An order can have many order items, but it has to have at least one order item for it to be an order. Otherwise, it's not an order. If you order nothing, then you're not ordering anything. So in this case, an order you can have multiple items in your order, or you can have one item, but you cannot have 0 items. Now, if I take an order item and I turn it around and say, well, what does this tell me about orders? Well, if I pick one order item out of here, I have to have at least one order available to me. I cannot have more than one order, because otherwise then it would defeat the purpose, first of all, of having order items as an intermediate table, but it also would not be accurate. Now, if I look at order items in terms of items, then that's a different story. So now, an order item can contain one and only one item. It represents each item in an order. Whoops, I went the wrong way though. So items, let me just click twice. So this is the one and only one item that can be represented in an order item. Now, if I look at items in terms of order items, if I look at items and I pull one item out of this items bucket, then this one item can actually be contained in several order items. But you can also have an item that's not associated with an order at all, which is why the 0 is here, or the O. The crow's foot is there to represent that there are many items that can be, there are many order items that can contain many items. And that is basically how you represent data in an ER diagram.